Hello, welcome to everyone in this video. In this video, I want to discuss about the question in the asked in JAM 2025. Already we discussed 20 question in previous 4 part. Today we want to discuss question number 21 to 25. So let's start. First question says that a unpolarized light ray passing through air, refractive index 1. So this is the air whose refractive index is 1, is incident on the glass slab whose refractive index is √3 at an angle 60 degree. This angle is 60 degree as shown in this figure. The amplitude in the xy electric field component of the incident is this. So this is in xy plane. So this we can say this is in the plane that is the parallel. So E initial that is the incident parallel whose magnitude is 4, right? And the amplitude is the z component is 3, that is the E incident perpendicular, which is 3. After passing through the glass slab, electric field in the light. So after passing through the glass slab, what will be the transmitted? This will be the transmitted part. So what will be the electric field of the transmitted part? So transmitted part, actually for that we need to know about the booster angle, and in the booster angle we know tan theta b we can say that is the refractiveness of glass divided by refractive of air. So that is √3/1, that is tan 60 degrees. So theta b is equals to 60 degrees. So booster angle is that angle in which the incident, if the ray is incident, then the reflected light is completely polarized. Reflected light is completely polarized. So for that we can say that is the E transmitted parallel, which is nothing but the E initial parallel, that is the 4. So this is the 4. Then what about the perpendicular part? So E transmitted perpendicular is formula is like that: E incident perpendicular multiplied by 2 refractiveness of air cos theta incident theta I, that is theta incident, then Ng refractiveness of glass theta I plus refractiveness of air cos theta t transmitted part. So what will be the transmitted part? So for that we use the Snell's law. By Snell's law we can say 1 into sine 60 degree is equals to √3 into sine transmitted part. So this is the theta t. So sine theta t 1 by √3. So sin 60 is √3/2, and this is √3 sin theta t. Hence sin theta t is equals to half, that is the sin 30. So theta t is equals to 30 degree. So if we put this value, that is 3 into 2 into 1 into cos 60 degree divided by Ng, that is the √3 into cos 60 degree plus 1 into cos 30 degree. So if you put this value of this expression, that is cos 60 is half, and this is √3/2, and cos 30 √3/2, so this is √3. So this cancel out, so it gives you √3, that is the 1 point. Okay, √3, no problem. So what about the total electric field? So E total we can say vector sum, that is the E transmitted parallel, E transmitted perpendicular. So this gives you root under 4 square plus √3 square. So this is root under 16 plus 3, that is 19. So this gives you above 4, nearly 4.3. So we can say this is about 4. So this is the 4. So option B is the correct answer of this question. Option B is the correct answer of this question. Clear about this question. Next question says, consider a slowly charging parallel plate capacitor distance is d, having the circular plate, the electric field is like that, the associated magnitude of the magnetic field. So within the parallel plate capacitor, the electric field which is changing arise the displacement current density. So volume displacement current density JD is nothing but epsilon naught del E by del T. So if you partial derivative of this electric field with respect to T gives you omega E naught cos omega T. So this is JD. From that we can say the current, this is the volume current density, or this is the linear current density I, that is nothing but JD into area. So this gives you area epsilon naught omega E naught cos omega T. Right. Now if we apply the modified Ampere's law, that is the closed integration of B dot dl is equals to mu naught I. Here I is ID, drift drift current, displacement current, right? So ID is displacement current, displacement current, right? So if you use this, that is the cycling integration, so B into dl integration is 2 pi r mu naught ID, ID is A epsilon naught omega E naught cos omega T. So this B gives you, that is A epsilon naught omega E naught, there is a mu naught and 2 pi r and cos omega T. Here you can say there is no r, so area is nothing but pi r square. So r is root under a by pi. So put here root under a by pi. So this gives you a epsilon naught mu naught. Epsilon naught mu naught is nothing but c square, right? So 1 by c square. So this is 2 c square pi, and r is nothing but root under a by pi. So root under a by pi. Okay. This is omega E naught cos omega T. So this a root pi cancel out. So this gives you 1 by 2 c square root under a by pi omega E naught cos omega T. So cos omega T are same things, under a by pi omega E naught cos omega T. This is c square a by pi omega cos omega T, 1 by 2 is cancelled out. So this is the correct answer. Option A is the correct answer of this question. Option A is the correct answer of this question. Clear? Next question. Next question says a surface current density is given by k equal to a to the power minus y, a thin strip of with B as shown in this figure below. The associated surface current. So you need to find out the surface current. So surface current I is nothing but integration k dy. So integration k y is value varies from 0 to b. So k is nothing but a e to the power minus y dy. So this is a e to the power minus y. So there is a minus 0 to k. So this is a minus e to the power minus k e to the power 0. E to the power 0 is 1. So this is a 1 minus e to the power minus k. Sorry, this integration is b, not k. This is b. This is b. So this gives you b. Integration limit is b. So option A. So option A is the correct answer of this question. Option A is the correct answer of this question. Next question. Next question says that for a electromagnetic wave, consider the electric field is like that. So this is in xy plane and electric field is k axis. You need to find out the corresponding b. So this wave propagate along the xy plane. So the wave vector, this is wave vector, unit vector, wave unit vector of wave, unit vector along wave is like that. is the k cap equals to nothing but the k vector, which is x I cap plus y j cap, and this is root under I cap plus y, so this is root 2. Actually not k, this is a. So this will be a root 2. So these two are cancel out, 1 by root 2 I cap plus j cap, right? So this is the k vector. So B, the magnetic field, is 1 by C k cross E. K is not the unit vector along z axis. This is the wave vector, right? So just taking this cross product, this 1 by root 2 I cap, j cap, k cap, and I cap coefficient 1, j cap coefficient 1, k cap coefficient 0, and this E along this total things taken as ek. So this is 0, this is 0, this is ek, or Ez you can say. Ez is nothing but this constant term, that is E0 e to the power minus iota a x plus y minus omega t, right? So if you taking this cross product, 1 by c, 1 by root 2, so I cap Ez minus j cap, this will multiply this Ez. So this gives you 1 by c root 2 Ez is common, I cap minus j cap. So I cap minus j cap only present in here, and if you put this Ez, this is the same thing. So option A is the correct answer of this question. Option A is the correct answer of this question, right? Next question. Next question says that consider the Maxwell relation. This is the Maxwell relation. The equation of state of thermodynamics is given here. So you need to find out Cv. We know that is the dq is equals to Cv dt, and dq ds equal to t, dq equals to, again in terms of entropy, this is tds. So Cv dt is equals to tds. So you can say Cv is nothing but T del S del T, constant volume. So del Cv del V as constant volume, a constant temperature, you can say that is T del 2S del V del T. So this is nothing but del T of del S del V, and del S del V is nothing but del P del T. So this is T del T of del P del T. So this gives you so that is del Cv del V at constant temperature is nothing but T del 2P del T square. So you just partial derivative of this function, that is P is nothing but AT by V square plus BTQ by V. So if you taking the partial derivative with respect to temperature, this gives you A by V square plus 3b t square by v. If you again derivative with respect to temperature, this gives you 0, and this is 6b t divided by v. So put here, that is t into 6b t divided by v. This is 6b t square by v. Hence this varies as the, that is del V at constant temperature varies as t square. So here the answer is option number A is the correct answer of this question. I think clear. If any doubt, you must comment in the comment box. Okay, so thank you. We will meet you in the next video as soon as possible. Thank you.